Okay, so this is our first practice problem for two-dimensional kinematics. And before we get started, I want to say if you have not solved this problem yourself, you want to go back and solve the problem before you watch this video. If you're stuck, send me an email. I'll give you a hand on how you do things, but watching the videos is not going to help you solve anything. So you really want to kind of do it yourself. Train your brain how to think through this. If you're getting stuck, let's get those questions answered. So it says a tennis ball is struck horizontally with a speed of 28 meters per second. The ball hits the court a horizontal distance, 19.6 meters away, and it asks what is the height. I'm going to highlight that in a different color when it leaves the racket. So first thing I want to do is draw it. So here's the ball. It's hit horizontally. It's going to have sort of a curved path, and it's going to hit the ground 19.6 meters away. And it's asking me to find this height here. Alright, so now I can start filling in my table. We know that my initial velocity in the y direction is 0 meters per second. It's hit horizontally. This tells me there's no vertical component of that initial velocity vector. We can see it's horizontal, purely horizontal. So this is plus 28 meters per second based on the way I've set it up in a standard reference frame. This is positive and this is positive. I do not need to put those here. It's assumed and understood. We know that the acceleration in the x direction is 0 meters per second squared. So that means that my initial velocity and final velocity vectors in the x direction are the same, so I'm just going to write those down. They tell me the horizontal displacement from here to there is plus 19.6 meters. And they ask me to find the vertical displacement. That's what this height is. This is my vertical displacement. So that's what I want to find. Now I have to take a look at kind of what I'm missing here. I'm missing my y acceleration. We know that it's 9.8 meters per second squared down. And I don't know the final velocity, and I don't particularly care because that doesn't really help me here. So as I look at this, I have three unknowns in the y direction. I can't find anything from that. So that means I will need this time in order to find my final variable. And so you can see I have enough information in x to be able to find t. So I'm going to use my x naught equals v naught xt. I'm going to solve that for t. So t equals x, sorry, this is not x naught. Over v naught x. I'm going to solve that in just a second. And then once I find that time, I'm going to plug it into the no vf formula in the y direction. And that was y equals v naught y t plus 1 half a y t. Alright, so let's solve this problem first. So t is equal to, here's my horizontal displacement, 19.6. You'll see me leaving my signs in there just to reinforce that you can't drop those off. With the positive signs, it doesn't make as big of a difference, but it's a good practice. So t is equal to 19.6 divided by 28. We're going to plug that into our calculator. And we're going to get 0.7 seconds. Time is a scalar. It will not have any kind of sign associated with it. now we take and we place it back up into here. My initial y velocity is 0 meters per second, so I don't have to worry about that. So this formula becomes y equals 1/2 a sub y t. I am trying to find the y displacement. This is what I am trying to find. So I'm set up fine to just plug in. So y equals 1/2 times negative 9.8 times the time 0.7. So my y displacement, we're going to plug that in, 1/2 times 9.8 times 0.7, that was a negative 9.8. So I have a y displacement of minus 3.43 meters. So my answer, they didn't ask for the y displacement. I kind of have to find it in a way, but I'm going to kind of translate that. It is 3.43 meters above the ground. They asked for the height. So I'm 3.43 meters above the ground.